All right, now that we have logarithms learned and studied, let's take a look at how they can apply here in video 0.5.6. No new vocabulary, no new theorems or rules. Here's an example. Sarah invests $1,000 in an account that earns 5.25% interest compounded annually. How long will it take the account to reach $2,500? Very similar question to what we would have seen in the exponential functions section, but all of those we solved with graphs. This one we're going to solve analytically with our properties of logarithms. So first, let's set up the problem. We're going to invest $1,000 and we're going to do it at 5.25% interest compounded annually. So we're going to multiply by 1.0525, and then this is raised to the power of t for years. We want to know how long it's going to take this expression to become 2,500, or in other words, how long will it take our $1,000 at 5.25% annual interest to become 2,500? Now, first of all, I do see some algebra. We can divide both sides of this equation by 1,000 and simplify the process a little bit. This becomes 1.0525 to the power of t equals 2.5. Next, we have this exponent t that we're trying to solve for. It's in an exponent. We might remember from the last video that we have a property that says if we are taking log base a of x to some exponent y, this exponent in the log can come out as a scalar multiplier, and this expression becomes y log base a of x. We're going to use that property to take the t as an exponent out in front as the scalar, then it's on the line and we can solve for it. Now, the simplest way to do that is to not use a log base a, but to use a natural log. That one's usually the quickest to work with. So let's take the natural log of both sides of this equation. And what we can do now is we see natural log of a base raised to a power. Power is going to come out front. So now we've got t times the natural log of 1.0525 equals the natural log of 2.5. And then we can divide both sides of this by that natural log of 1.0525 divided by the natural log of 1.0525. And then with a simple scientific calculator, we're going to type in the natural log of 2.5. We're going to divide it by the natural log of 1.0525. And we'll probably find out that this is about 17.9. And here we are in years. So without a graph this time, we used a property of a logarithm to solve for how long it takes to bring an initial investment of $1,000 up to 2,500. So that is it for this whole entire section.